So I think the best way to learn how to do Gauss-Jordan elimination is first by watching it being done, and then you really just have to practice it a bunch. And it's a pretty specific process that you have to follow, otherwise you're going to mess up a bunch of work that you've done already. So as we outlined in the explanation of how to do this in the reading above, uh, what we're after is to look at this main diagonal here and turn each of these elements into a 1, and then all other elements in the matrix, we want to try and make those zeros. So it's, again, a pretty specific process. We start off in the position 1, 1, and we try and make that a 1. In this case, it already is, so there's really nothing to do there other than now try and turn the remaining elements in that column into zeros using our row operations. So we can do that, and we'll go ahead and get started by multiplying the top row by -2 and then adding it to the second row. And what that's going to do for us is eliminate this particular number or turn that number into a 0. And so let's get our matrix set up here. For the time being, we're happy with the top row, so let's rewrite that. And we're going to create new second and third rows by making some replacements. So what we're going to do is we're going to take initially here, create a new second row by taking -2 times row 1 plus row 2. And again, that'll give us a new second row. So let's go ahead and work through this. We're going to do some multiplication and addition. -2 times 1 is -2, plus the 2 is 0. This was specifically by design. So that's going to be 0. And then we just work our way across the matrix. So -6 and 5 is -1. +2 and -1 is going to be 1. And -4 and 6 is going to be 2. So there's our new second row. And it just happens in this case that if we multiply the top row by -2 and add it to the third row, we can also make this second 2 here as 0 as well. So we get the same multiplier. And our new third row then is going to be -2 times row 1 plus the old row 3. And again, we're going to do some similar calculations here. So we get -2 times 1 is -2, plus the 2 is 0. Here we multiply and get -6 and 8, which is 2. We get +2 and -2, which is 0. And -4 and 6 is 2. So now we have our new third row. Now we work our way down to the next diagonal position, position 2, 2. And we want to turn this into a 1. So this is done pretty easily. We'll just go ahead and multiply that row by -1. So again, let's set up our matrix here. Row 1 we'll rewrite since we're happy with it again for the time being. And now I'm going to take -1 times row 2, and that's going to be my new row 2. Maybe I'll put this notation out back. So now I get a row that looks like 0, 1, -1, -2. And again, we're happy with row 3 for the time being. And you may be thinking, should you go ahead and divide row 3 by 2? You could definitely do that. I'm just going to go ahead and hold on to it for right now and kind of continue with the general process though. So now we've got a 1 in the next diagonal position, and we want to use that and row operations to turn the remaining elements in that column into zeros. So the 3 and the 2. So again, let's set up our matrix. And we're happy with row 2 for the time being. 0, 1, -2, or rather -1, -2. And we're going to create new first and second rows that have, again, zeros here and here. So that's our goal. So let's go after that new top row maybe. And in order to create a 0 here, I'm going to have to multiply the second row by -3 and add it to the top row. So we want -3 times the second row and then adding it to the top row. So that's going to be our new top row. So -3 times row 2 plus row 1. And here we go with our multiplication and addition. So I get a 0 and a 1, which is a 1. Get -3 and 3, which is 0. +3 minus 1 is 2. And then 6 and 2 is 8. So there's our new top row. And we'll do that process again. But you'll note that in order for us to zero out this position, I'm going to have to multiply the second row by -2 now this time. So we'll take -2 times the second row plus the third row for our new third row. And here we go again with some more multiplication and addition. So we get a 0 from the product, and 0 is 0. I get -2 and 2, which is 0. Again, that part was by design. We wanted that to be 0. +2 and 0 is 2. And on this one, the last one here, we get +4 and 2, which is 6. So now we've got our new third row. So now we move to the next diagonal position, in this case 3, 3. And I want to turn that into a 1. Now we can do that pretty easily by just multiplying by 1/2 or dividing by 2. Again, let's set up our matrix. And we're happy with everything else. 0, 2, 8, 0, 1, -1, -2. And now we'll do our new row 3 by cutting everything in half. And just to notate it, this was 1/2 of row 3 from above. And now I've got that position as a 1. We want to turn everything else in that column into zeros, again using those row operations. So one last time here, we'll go ahead and figure out what we need to do. We're happy with row 3, it's done. And now we want a new first and second row. Let's go after that new first row. So if we look, I have to multiply 1 by -2 so that when I add it to the top row, that position becomes a 0. So we are going to take -2 times row 3. And that's not the right spot. Let's go ahead and get that up. So we are going to take -2 times row 3 and add it to the old row 1 to get our new row 1. So -2. And here we go. I get 0 and 1, which is 1. 0 and 0 is 0. -2 and 2 is 0. And -6 and 8 is 2. So that's our new third row, or rather our new first row. And now we'll just grab that new second row. And you'll notice here, if we just simply add the two rows together, then our position here will zero out. So our new second row is just going to be row 3 plus the old row 2. And if we just add those together, I get 0, 1, 0, 1. And now we're done. We can easily read off the solutions. Remember that first column is the coefficient on x1, x2, x3. The bar is the equals, and of course the constants are over here on the right-hand side. So that top row is really telling us that x1 equals 2. The second row is really telling us that x2 equals 1. And the last row is saying that x3 is equal to 3. And there you have the solutions to the system of equations that this matrix represents.